My name is Israel, and I'm 5 and like bacteria.
So I'm Brian Fleger. I'm an associate professor here in the Department of Chemical and Biological Engineering at UW-Madison. Bacteria are amazing single-cell, very simple organisms. They're everywhere on the planet in all sorts of different environments, from your gut to the soil to hot springs to the Arctic and the Antarctic. So every type of environment you can possibly imagine, people have isolated bacteria, and they do amazing things, from chemistry to things that help human health to things that are used in biotechnology. So my research is primarily focused on biotechnology, and so we're interested in using living organisms to do things for human society. And so classically that's been used in the production of pharmaceuticals, so whether those are protein drugs or small molecules like antibiotics. But increasingly they're being used to look at ways of making chemicals. And so in chemical engineering, that's our focus, is how do you design processes to convert resources that we have, and so typically those are petroleum or fossil fuel resources. But increasingly now we're starting to think about ways to tap into biomass and other renewable resources to try to get at some of the same chemicals and materials that we use in all sorts of applications. And primarily, since we're talking about chemical production or chemical decay, we're growing cells on a certain feedstock and then we're analyzing what happened. So you watch whether or not the feedstock decreases with time, and you watch to see if your product is increasing with time. And then you compare and contrast these between experimental and control cells. And so as I said, they come from all walks of life, but the one that's typically used in engineering applications is called Escherichia coli, or E. coli for short. And so you've probably heard about him or her from the Jack-in-the-Box food scares or other types of health issues. And so we use that organism because we know so much about it, but also because it has wonderful traits. And so we can grow it very quickly on a wide range of different types of cheap materials. We can manipulate it genetically, so we can change the genes, the blueprints in the organism, and we can use that to our advantage to give it new properties, say new pathways for producing or converting glucose into molecules that might be useful in either plastics or biofuel applications.